Good morning, students. So far we have discussed about concept of inverse trigonometric functions, their graph. Now we'll be discussing about properties of inverse trigonometric functions. Let us understand the properties. It will facilitate evaluation, simplification of our problems. Now property 1, sine of sine inverse x is equal to x for x belongs to minus 1 to 1, cos of cos inverse x, again x belongs to minus 1 to 1, tan of tan inverse x is x belongs to r, cot of cot inverse x is equal to x belongs to r, sec of sec inverse x is equal to x. For mod x is more than equal to 1, and this can be thought of in this way also, that x belongs to r minus 1 to 1, and cosec of cosec inverse x is same. Now these all, only the thing, important thing here is this we can write only when x is from minus 1 to 1, otherwise not. This is what you have to keep it in your mind. Now the proof is very simple. Let sine inverse x is equal to y. So since it is an invertible function, inverse of invertible function is also invertible, so we can write x is equal to sine y. And so if x is equal to sine y, we will replace y here by the value of y, means sine inverse x. It means x is equal to sine of sine inverse x. So we can write sine of sine inverse x is equal to x. Again, I am emphasizing on the point that it is true when x belongs to minus 1 to 1, or this is also written as mod x is less than equal to 1. Now we'll see with the example. Evaluate sine sec inverse 17 by 15. Now for this kind of problem, what you have to see, if sine is outside and it is not sine inverse, so we need to convert this in terms of sine inverse. For converting this, what we'll do, we'll write this as x. Now take the triangle. It's a very simple way of getting it converted. So if you're taking the triangle, so sec inverse is sec x is equal to 17 by 15. So we can write sec is what? H by b. So we can write this in this form, 17 by 15. So we can calculate by applying Pythagoras theorem. So we'll get it at 8. So we can now write sine x as 8 by 15. So we have got sine x as 8 by 15. So we can write x as sine inverse 8 by 17. It means your sec inverse 17 by 15 can be written as sine inverse 8 by 17. Now we'll evaluate. So sine of sec inverse 17 by 15 can be written as sine of sine inverse 8 by 17. Now you just see this 8 by 17 is in between minus 1 to 1. So as per the property, we can write sine of sine inverse x as x if x is from minus 1 to 1. So you have got the answer as 8 by 17. Now let us see the another property. What is another property? Sine inverse. Here inverse is outside, sine x is inside. So sine inverse sine x is x. Again here x should belong to the principal value branch, means minus pi by 2 to pi by 2. Again on the same line, all will be having the thing, your x part you should be careful. X should be what? So we know that sine inverse, tan inverse, these are all, and again you are having your cosec inverse, they are all minus pi by 2 to pi by 2. One is closed, one is open, and cosec inverse is again closed except 0. And on the same way, cos inverse, cot inverse, and sec inverse, they are all 0 to pi. One is closed, open, and it is closed other than pi by 2. Proof is again very simple. So let sine x is equal to y, so we can write x is equal to sine inverse y. So x is equal to sine inverse, the value of y is sine x. It means sine inverse sine x can be written as x. Again I emphasize that where x belongs to minus pi by 2 to pi by 2. So we'll see with the help of an example how we apply this. Now evaluate. Our question is now evaluate tan inverse tan 3 pi by 4. We cannot write tan inverse tan 3 pi by 4 as 3 pi by 4. Why? Because this 3 pi by 4 does not belong to the principal value branch. Here it should be in between minus pi by 2 to pi by 2. So what you have to do now? You have to change so that it fits in within the domain. Now, we can write 3 pi by 4 as pi minus pi by 4, and we know tan pi minus theta is minus tan theta. Again, it is tan inverse minus 10 by 4. So this minus should not be there. So we can again write tan of minus of 10 pi by 4 can be written as 10 minus pi by 4. So now we have got that has been written as tan inverse tan, and the angle is minus pi by 4. So minus pi by 4 is within minus pi by 2. It fits it into this part, means it is in between minus pi by 2 to pi by 2. So we can write tan inverse tan minus pi by 4 as minus pi by 4. So after evaluation we have found. So again, what is very important, that the domain part, it should fit in, then only we'll apply. Now let us see the third property. Third property is what? Sine inverse minus x is minus sine inverse x, tan inverse minus x is minus tan inverse x, and cosec inverse minus x is minus cosec inverse x. These are same, we have learned it in the trigonometry in class 11. But for cos inverse minus x, cot inverse minus x, and sec inverse minus x, it is not cos inverse x, it is pi minus cos inverse x, pi minus cot inverse x, and pi minus sec inverse x. We will see one proof. Let us see this proof. Now let cos inverse x is equal to y, so we can write x is equal to cos y. Here we can write only when y belongs to 0 to pi, principal value branch. Now, so minus cos x is what? Minus cos y, we have multiplied. Now we can write minus cos y as cos pi minus y. We know cos pi minus theta is minus cos theta. This can be written in this form. Again, whether cos can be transferred this side or not, it depends upon whether pi minus y belong to 0 to pi or not. So that we have to check it here. Either it mine or you show it. So we know that y is from 0 to pi. So minus y. So if you multiply by minus, the whole inequality gets reversed. So we have got this, or we can write this in this form. Now if we add pi in the whole inequality, there is no problem. So we get pi minus y is from 0 to pi. If it is pi minus y, and since it is 0 to pi, so we can write cos as cos, we can transfer is this side, otherwise not. So we are getting that cos inverse minus x is what? Pi minus y. So what is y? Cos inverse x. It means cos inverse minus x is pi minus cos inverse x. Other proof you can do it by yourself. Now we'll see one example. Now evaluate this. So what we have got? Sec inverse minus root 2. Sec inverse minus x. So we know sec inverse minus x is what? Pi minus sec inverse x. So this can be written in this form. Again, root 2 will be thinking of whose value is root 2 in sec. So we know it is sec pi by 4. So sec inverse sec pi by 4 can be written as pi by 4 because it is within the principal value branch. So we can write as pi minus pi by 4. So it is 3 pi by 4. Now let us go for the next property. Next property is what? Cosec inverse x is sine inverse 1 by x. Sec inverse x is cos inverse 1 by x, and cot inverse x is tan inverse 1 by x when x is positive, and pi plus tan inverse 1 by x when x is negative. This is very important to note that for positive we will be taking, we can write in this form, but for negative we have to write in this form. So we will see the proof of this part. Now we will be having two cases when x is more than 0. So let cot inverse x is equal to y. So as x is positive, we know that cot inverse x is equal to y, and the principal value branch means y should be from 0 to pi. But as x is positive, then it has to be in the first quadrant. So here the y will be taking at 0 to pi by 2. So now we can write x is equal to cot y now. So take the reciprocal, 1 by x is equal to 1 by cot y, and 1 by cot y is equal to tan y. So what we have now, that 1 by x is equal to tan y, and so now since y is within the principal value branch of tan, so tan can be brought on the left hand side. So we can write y is equal to tan inverse 1 by x When we are writing this, when x is positive. Now the next case, when x is negative. Again, similar way, cot inverse x is equal to y. As x is negative, then it has to be in between, in the second quadrant. Means y should be more than pi by 2 and less than pi. Now see it here. If y is this, now again take subtract the whole inequality by minus pi. So this is 0, this is minus pi by 2. So we are getting that y minus pi is minus pi by 2 to 0. Now here x is equal to cot y. Again on the same line, 1 by x is equal to tan y. Tan y, we can write this as minus tan pi minus y. Why? Because tan pi minus y is minus tan y. And we want to write tan y, so we can say minus. So minus of tan pi minus y is tan y. Now again, if you are taking minus common from the bracket, so tan of minus y is minus tan y. It means this we can write in this form also, minus tan, take minus common, so you are getting y minus pi. So tan of minus theta is minus tan theta, so they will get neutralized. So we'll be getting this as what? Tan pi y minus pi. Again, we have to see whether tan can be brought this side or not. It can be brought to the left side only when it is in the principal value branch. And we know that y minus pi is minus pi by 2 to 0. It is within the principal value branch of tan inverse. So we can write tan inverse 1 by x as y minus pi. So now what is y? So y pi is this side, so pi plus tan inverse 1 by x. It means cot inverse x is pi plus tan inverse 1 by x when x is less than 0. So this important property you must remember, that for positive what we have, for negative what we have. So for positive we write cot inverse x as tan inverse 1 by x, and for negative we write cot inverse x as pi plus tan inverse 1 by x. And very important property, common, very common use, sin inverse x plus cos inverse x is pi by 2. On the same line, tan inverse x plus cot inverse x is pi by 2, and sec inverse x plus cosec inverse x is pi by 2. Again we are writing the domain of x. Now let us write sin inverse x is equal to y, so x is equal to sin y. Now we write thinking that y is in the principal value branch, means minus pi by 2 to pi by 2. So now first we can write sin x is equal to sin y, and sin y can be written as cos pi by 2 minus y. Cos pi by 2 minus y. So now whether we can write cos this side or not, so we have to see where it lies. Pi by 2 minus y lies where? Just see this side. Y is minus pi by 2 to pi by 2. So minus y, inequality gets reversed after multiplying it by minus. That can be written in this form, minus y more than equal to minus pi by 2 and less than equal to pi by 2. Now you add pi by 2 in the whole inequality. It becomes pi here, it becomes 0 here. So pi by 2 minus y is 0 to pi. It is within the principal value branch of cos inverse. So we can take cos on the left hand side. We can write cos inverse x, and this gives you the principal value pi by 2 minus y. It is from 0 to pi. So now we have got cos inverse x as pi by 2 minus y. So take y on the left hand side. So y plus cos inverse x is equal to pi by 2. What is y? Sin inverse x. It means sin inverse x plus cos inverse x is pi by 2. These are some important properties in the inverse trigonometric function. There are some more. We will discuss that in the next class. Based on this, we will be doing the questions now. Thank you very much.